according to some people, they like to believe that Gleason said the map that he made, this Gleason's flat Earth map, was not accurate. Airplane flights and emergency landings prove otherwise. But anyways, I just want to show you this right here. Scientifically and practically correct as it is. And if you come down here, published by the Buffalo Electrotype and Engraving Company, Buffalo, New York, USA. Hey, Professor Dave, there's your scale. You gotta know how to read it. You gotta be a little intelligent.
From 1892 that states at the top that it's scientifically and practically correct as is. We see this Antarctic ice rim. The Gleason's map is basically an azimuthal equidistant projection, which can be traced back to the year 1000. The AE map is also an official map of the United States Geological Survey, the USGS, and the official logo for the United Nations. The oldest known globe in the world is from 1492. This is something you need to keep in mind because many people argue that the azimuthal equidistant map is just a flattened out version of the globe, when in fact the globe is just a rounded version of this true world flat map.
Today we're going to measure some distances on the Gleason's map. But first of all, the Gleason's map is a longitude and time calculator. This is very important. It's a longitude and time calculator. So it's not meant to measure distances, but we'll get into that. There's another very interesting thing about this Gleason's map is this scale. It says English miles corresponding to the nautical miles, 60 miles to the degree. Let's have a quick look at the GPS survey, and we found 69 miles. So 1 degree of latitude equals to approximately 69 miles. On the Gleason's map, it's 60 miles to the degree. So we're going to convert the 69 miles to nautical miles and see the difference. It's 69. 69 miles is approximately 60 nautical miles.
This is the scale on the Gleason's map. English miles corresponding to nautical miles and 60 miles to the degree. This is the English miles and this is the nautical miles. 69 miles is approximately 60 nautical miles. This should have been nautical miles, not miles. Both of them can be miles. 69 miles is approximately 60 nautical miles. This is the scale on the longitude line. The longitude line is divided in 15 degrees latitude line. So this is the scale for the longitude lines. If you want to use 69 miles or 59.9594 nautical miles, it's up to you. Feel free to do so.
Back to the Gleason's map. Between the latitude lines, these are the latitude lines, you have 15 degrees, 0, 15, 30, so it's 15 degrees between the latitude lines. The scale is 60 nautical miles to the degree. It is 15 times 60 nautical miles, and that is 900 nautical miles between the latitude lines. Let's use trigonometry to measure the distance from Morocco to Georgetown in Guyana. We're going to measure the distance in centimeters. But before we do that, let's find the coordinates of Georgetown and Morocco and compare them with the GPS survey, just to be sure we are measuring from the same location.
Let's measure the coordinates of Georgetown. This is Georgetown. This is the equator. So we have above the equator this north, and if we divide the 50 lines degrees, I'll measure 5, 6, well, let's say 7, less, just a little bit less than 7, but I'll go with 7 degrees north. This is the 7 degrees north. So if I want to measure the longitude line with my ruler, I will measure it at exact 7 degrees north. To measure the longitude line, I have to place my ruler on the North Pole. This is Georgetown in Guyana, and then I have to move the ruler to the exact location. So there. And I can read the degree from the meridian of Greenwich. It is 15 degrees, 30, 45, it is 45, 50, 55, 56, 57, 58, and 58 and a quarter. So I'll say minus 58 and a quarter degrees. Now let's compare it with the survey and see what it is.
The survey says 6.8 degrees north and minus 58.15 degrees west. We are on the right spot. We found 7 degrees north and minus 58 and a quarter degrees west. We can do it with 7 degrees north and minus 58 degrees west.
These are the latitude lines from the equator. Above it's north and below the equator south. Morocco is at 15 degrees, 30 and something more. There are 15 degrees between the latitude lines. So if you divide the latitude lines in degrees, you can measure the exact location. It's between 31 and 32. It's between 31 and 32, so I will say 31.5 degrees north. So I have to measure from the North Pole to the same degree. So if I look at the ruler, it is 10.7 centimeters. That's the distance from the North Pole to Morocco. That's the longitude line from the North Pole to Morocco.
The next step is to find the longitude coordinates, and you can do that by reading the degrees on the circle of the Gleason's map.
And it's 7 degrees. This is the meridian of Greenwich. This is 5 degrees, 6, 7 degrees west. So it's minus 7 degrees. This is east and this is west. So it's 5, 6, 7 degrees west, minus 7 degrees. Let's compare it with a GPS survey and see what it says.
For Morocco, the coordinates are 31.17 degrees north and minus 7.33 degrees west. We found on the Gleason's map 31.5 degrees north and minus 7 degrees west. Again, the Gleason's map is pretty accurate. Of course, it is a longitude and time calculator.
The last thing we have to do is to read the angle between Georgetown and Morocco. Morocco is at 7 degrees, minus 7. Georgetown is 58 degrees. So this one is 15 degrees, 30, 35, 40, 45, 46, 47, 48, 49, 50, 51 degrees. So it's 51 degrees between Georgetown in Guyana and Morocco.
We have collected all the data to calculate the distance between Georgetown to Morocco. From the North Pole to Georgetown is 15 centimeters, from the North Pole to Morocco 10.7 centimeters. By doing some trigonometry, we found the answer of 11.72 centimeters. So the distance between Georgetown to Morocco is 11.72 centimeters.
From Georgetown to Morocco, we calculated 11.7 centimeters, and as you can see, if we measure the distance, it is exactly 11.7 centimeters.
The question is, can we calculate the ratio and then use this ratio to calculate the real distance between Georgetown and Morocco? The answer is no. And I'm going to explain why not. Let's assume I discover a whole new continent and I'm going to scale it down on a piece of paper, and I'm also going to scale the distance between the island and my location. This is my location and each dot represents 5 centimeters. So this is 5 centimeters, 10, 15, 20, 5, 10, 15, 20, 25. And I'll start drawing the new continent, and it will look like this. This is the new continent. And after a while, I decided to build a few cities. The scale is 1 to 4. It means 1 centimeter is in reality 4 nautical miles. That's the scale I used to draw the new continent on a piece of paper. Now we're going to draw this continent on the Gleason's map, and I'm going to use the same coordinates on the Gleason's map and also the same scale on the longitude line. And this is how it looks like on the Gleason's map, with the same coordinates on the longitude line, the same distance. If you scale it on the longitude line, it will be the same. All the cities have the same coordinates. But now you can see you have a problem on the latitude line because it is not scaled in the Gleason's map. This is scaled only on the longitude lines, not the latitude lines. If I lay the drawings on top of each other, it will look like this. All the coordinates on the longitude lines are the same, but as you can see, it is stretched out because the latitude line is not scaled. The Gleason's design is drawn on a circle and it is scaled on the longitude lines. In this case, 2 east, 4 south. You can choose your own design and the coordinates will be the same. 2 east, 4 south. 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 If you scaled on the longitude line, you can calculate the real distance on the longitude line. You can draw it on the pyramid, you can scale it, but it doesn't mean the world is a pyramid. can we use a different design so we can lay these two drawings on top of each other and compress Gleason's drawing to match the scale of the original drawing and with the same coordinates? It's possible. Yeah, you can take this Gleason's drawing, put it on a piece of paper, cut along the 1 degrees longitude lines, compress the lower part. Yep, looks good. Oh, it bends a little bit. Oh, no problem. We can stitch it on a ball. You can draw it on a sphere. It doesn't mean the world is a sphere. Back to the Gleason's map. We know the distance in centimeters from the North Pole to Morocco. We know the scale on the longitude line. It is 60 miles to the degree. Now we can calculate the ratio. We could do the same for Georgetown. Theoretically, both ratio should be the same.
Now I know the ratio of this map, so I'm going to measure on a longitude line between two cities. I chose Sydney, that is Sydney, to Kamchatka, and that is 15.8 centimeters. The coordinate of Sydney is minus 34 degrees, and 150, that's Sydney, is 150 and a half degrees, and for Kamchatka it is 53 north, and the longitude for Kamchatka is 157 degrees.
And if we go online and enter the same coordinates we found on the Gleason's map, the site calculates 5,234.57 nautical miles.
We can do the same between King George in Australia at the 0 to Peking in China, and that is 13.6 degrees. King George in Australia, that's 35.5 degrees south, and the longitude that is 105, 10, 15, 16, 17 and a quarter degrees. So 117 and a quarter degrees. Peking, I'll go with 39.5. Maybe it's 7, but I'll go with 39.5. And longitude, that's Peking. And the longitude is 105, that's 10, 15, 16, 17 and a half degrees. There's 117 and a half degrees.
Let's go online and enter the coordinates we found on the Gleason's map, and we found 4,503.06 nautical miles. The distance between King George, Australia and Peking, China, on the Gleason's map we measured 13.6 centimeters times the ratio is 330, and it is 4,488 nautical miles.
If you have managed to get this far, the easiest way is to place a piece of paper on the map, mark the distance on the longitude line and then go to the scale. Place the paper on the scale and then count the degrees. 15, this is 3 degrees, plus 9 degrees is approximately 24 degrees, times 69 miles, or 60 nautical miles. From Peking in China to St. George in Australia, you can do the same. Place a piece of paper on the map, mark Peking, mark St. George, then go to the scale, place it on the scale. It's approximately 76 degrees times 69 miles, or 59.9594 nautical miles, or just 60 nautical miles. There's a lot of information in this video. Do you understand what is going on?